Hey guys, what we're going to take a look at in this video is what we talked about in class today, a monohybrid cross, and using Punnett squares to predict what the offspring's genotype and phenotype are going to be if we know what the parents are. When we're doing this, I said we have a couple of vocab terms that we're going to need to know extremely well, and that's going to be determining dominant traits versus recessive traits. Now we know dominant doesn't mean better and recessive doesn't mean worse. Dominant just means that we need one allele to see this trait. And we get these alleles, one from mom, one from dad, and it's just two different forms of the gene. When we are writing a dominant trait, we always use a capital letter, and in this case I'm going to use a capital A to represent the dominant trait. Now because we get our genes from our parents, we get one allele from mom, the other one from dad. When we have the dominant trait, we could see that it is a capital A, capital A. We've received a dominant trait from mom and a dominant trait from dad. If these genes are the same, we say that this individual is homozygous. And homo means the same, and that's exactly what we see. Another way that we can see the dominant trait is if we have one dominant and one recessive. Because these genes are different, we call this heterozygous. But because we only need one allele to see the dominant trait, this person will still be dominant. Now with a recessive trait, we will need two alleles to see this. And we always represent the recessive trait with a lowercase. And again, I'm going to choose the letter A. The only way we're going to have a recessive trait show up is if they are homozygous recessive. So we would see a little a and a little a to be homozygous. So dominant, one allele, recessive, two alleles to see it, homo meaning the same, and hetero meaning different. A couple other vocab terms that we're going to need to know is the genotype and the phenotype of an organism. When we're talking genotype, this is the genetics of the organism. This is what we see in their DNA. So their genetics, they could be homozygous dominant, they could be heterozygous dominant, or they could be homozygous recessive. Now this is great to know because then when we know genetically what they look like, it'll then tell us the phenotype of the organism. And the phenotype is physically what this organism is going to look like. So maybe being capital, capital is going to give this organism brown fur. And then same thing with a capital lowercase. If brown is dominant, it's going to mask then having black fur. The only way we're going to get black fur physically is if we have the recessive phenotype. So little a, little a. So genetically, genotype, physically, phenotype. If we know that, we then can use a Punnett square to help us predict what the offspring are going to look like. Now, when we set up a Punnett square, I know you guys have had lots of practice with this before, we need to know the genotype of the parents. I'm just going to go with brown and black fur that we've started with. We'll just say that we'll use B's for this example, that a capital B is going to give brown fur, and a lowercase b is going to give us black fur. If we take a parent who's going to be heterozygous for brown fur, we know the genotype has to be one capital, one lowercase, because hetero means different. So I'm going to write my first parent up here. Heterozygous for brown fur. And let's say I want to cross it with a parent who is going to also be heterozygous for brown fur. The second parent's also going to have the same genotype, one capital, one lowercase. When we go to set up our Punnett square, we are going to figure out how these parents' alleles will segregate during gamete formation. With this parent, I'm going to go ahead and write their alleles that they could pass on across the top. And my second parent, I'm going to write down the side of my Punnett square. You can do it the opposite. If you want to write the first parent on the left and the second parent across the top. That's 100% okay. When we fill out our boxes, we're still going to get the same results. Starting with our first parent, we see this parent could pass along the dominant trait. So I'm going to write the first allele for the dominant trait in the box here, or above my box here. The second option this parent has is they could pass on the recessive trait. So I'm going to write the parent's second allele on the opposite side. I'm going to do the same thing to separate my second parent. It could pass along a capital B, or the dominant trait, or it could pass on the recessive trait. So I'm going to separate the alleles. What we're going to do now is we are going to combine the alleles, and that's what we're going to do inside each of these boxes. I'm going to drop down one allele, and I'm going to combine it with the parent's allele over here. So in this box, I'm going to have dominant trait from one parent and a dominant trait from the other. In my next box, I'm going to drop down the recessive trait, and I'm going to bring over the dominant trait. In our next box here, I'm going to write it the opposite way. I'm going to bring over the recessive trait first, and then I'm going to drop down the dominant trait. Like I told you in class, it doesn't matter if you write capital then lowercase, or you write lowercase then capital. I'm not going to be picky because these are going to give us the same thing. Its genotype is still going to be the same. It's going to be heterozygous dominant, and we're going to see brown fur for these. If we finish up our last box, if I drop down my little b and I bring it over, I have now filled out my Punnett square. The next step is then to look at what are the possible offsprings that these parents can have. And so we just have to go through box by box, look at the genotype, and then we can determine the phenotype. In my first box, out of my 4 options, I have 1 out of 4 could be capital B, capital B. They are homozygous dominant. Because they have at least one dominant allele, we know it's going to have brown fur. I then see 2 out of the 4 ways that these alleles can combine will be heterozygous dominant. 1 capital, 1 lowercase. Again, because there is a capital or a dominant trait, we know they're going to have brown fur. And the last way that their alleles can combine is we could have lowercase, lowercase, or recessive, recessive. So 1/4 of their offspring could be homozygous recessive and have the black fur. I'm going to go ahead and set a few more crosses up, still using the brown and black fur example. When you get enough practice with these, it will start to feel really easy, and you may not need to always work them out. But it's really important to know how to set up the monohybrid cross for when we get to the dihybrid cross, because it's going to be a little bit trickier, and you may not be able to do it in your head. Okay, in my next example here, I'm going to go ahead and cross a homozygous brown. So I will have 2 dominant traits. And I'm going to cross it with a homozygous black bear. So that's going to be 2 recessive traits. We're going to set up our Punnett square the exact same way we did last time. Now I know some of you guys can already do this in your head, but I'll show you how we set this up. Our first parent can pass on a dominant trait, so I write their first allele in the first section. And the second allele that they could pass on is also dominant, so I'll write the second option next to it. Parent number 2 has the option of passing on a recessive allele, so I'll write the first option over here. And its second allele it could pass on is going to be recessive as well, so I'll write it in the second spot. The next thing I do is I fill out my Punnett square. I'll drop 1 trait down, or 1 allele down, and I'll bring the other allele over. 1 allele down, the other allele over. 1 allele down, the other allele over. 1 allele down, and the other over. All said and done, we see 100% of their offspring, or 4 out of 4, are going to be capital B, lowercase b. They're heterozygous, and they're going to have the brown fur. If we take a look, we could do the same thing if we wanted to do homozygous brown with homozygous brown, big B, cross with big B. The only possible outcome we're going to have, I know you guys can do this in your head, they're going to have 100% of their offspring are going to be homozygous dominant, big B. It'd be the same thing if we crossed a homozygous recessive with homozygous recessive. When we work our Punnett square out for either of these, when we separate the alleles and fill in our boxes, the only options that we have would be 100% like the parents. We will have more practice coming up, and I will post more videos for you